All right, hey gang, I'm going to go ahead and try to work through this review as quickly as I possibly can. Hopefully it's clear and understandable, and then you're off to your test. So yeah, let me know if you have any questions here. So starting with the homework, the review here, it says this, make sure it's underneath. Write a function equation for the following problem and define the variables used within the problem. Renting an excavator will cost a flat fee of $100 an hour and an hourly rate of $75 per hour. So if I go ahead and do this, I'm going to put down C as the cost for the rental. And I'll put down H is the number of hours. Okay, so from there, my cost for renting this excavator, my starting point is going to be $100, okay? And then it's $75 per hour. So that's my equation. Part B says, how many hours would you have rented the excavator if the rental fee was $475? Well, if I go ahead and plug in $475 for my costs, and I solve for the number of hours, that's going to give me how many hours I would have rented it for. So how do I get the 75H by itself? I subtract the 100. And then if I divide everything by 75, I'm going to get the number of hours. So 375 divided by 75 gives me 5 hours of rental. Okay? Pretty good charge there to rent that. Are the following equations linear or nonlinear? So what I did here, and hopefully this will work, you've seen me try this before, I'm going to show you Desmos. There's the first equation. Obviously looks linear, right? So the first one is yes. If I use Desmos again for the second equation, the equation of a circle. Notice here the radius is actually 4. This is the radius, okay? The square root of that is the radius. And the x value is 0. The y value is up 4. I'll teach you about that next year in geometry. So here's the center at 0, 4, and it has a radius of 4. You can see that there's 4 right there, and then there'd be 4 on the other side, okay? So the second one is no, definitely not linear. And the last one, ooh, that's kind of a cool shape. Not linear either. So as we look at those, if I go back to this right here, I'm going to say yes, no, and no. Okay? So make sure you, use Desmos on those if you have questions. Determine the x and y intercepts of the following equations. Now, if you remember when we did this, we made up a little table. We plugged in a 0 for the x, and we also plugged in a 0 for the y. So if I plug in a 0 for the x, 0, and I solve for the y, okay, this is going to be gone. And then how do I get y by itself? I'm just going to divide both sides by 2. So y equals 9. So at 0, 9, this is actually the y-intercept. The y-intercept, okay? 0, 9, so I'm going to go up 9 on the y-axis. If I do the same thing for the y value, plugging in a 0 for the y value, now this is gone. And how do I get x by itself? I divide by 12. When I do that, I get 1.5. So my x-intercept is going to be 1.5 comma 0, or 1.5 over on the x-axis, okay? Number 6, determine the next 3 terms in the arithmetic sequence. Negative 36, negative 28, negative 20, negative 12. If you notice there, we are adding 8 each time. So if I add 8 to negative 12, I get negative 4. If I add 8 to negative 4, I get positive 4. If I add 8 to 4, I get 12, okay? If the formula for the arithmetic sequence is the following, determine the 102nd term of this sequence, okay? So this is my first term, negative 36. I'm going to the 102nd term, with a common difference of plus 8. If you want to put a positive in there, you can, okay? So if we work this out, I'm going to go ahead and get a little bit closer here so you can see everything just a little bit better. Maybe I'll refocus, okay? If we go ahead and work this out, I'm going to go ahead and type that in. What is it here? Negative 36 plus parentheses 102 minus 1 times 8. Oop, let's do that. Okay, 772. Okay, is what I'm looking at there for the 102nd term. 772. Okay. The next one, a helium balloon is released and measurements were taken for each second after the release of the balloon. The following chart shows the recorded data. Okay, so time released in seconds, distance from the ground in feet. Oh, excuse me, I shouldn't do that, sorry. Write an equation in the function notation for the relationship between the time released and the distance from the ground of the helium. So function notation, what that means is this, f of x, okay? So you could do this in several different ways. I guess what I'm thinking is this. I would do it, the starting point is 6, okay? That's my first term. And then from there, every second after has a common difference of 6 feet. Up 6, up 6, up 6, up 6. Okay? This is, you can fix this a little bit if you want to go ahead and write this out. We can simplify this by distributing that 6. And then from there, the 6's will cancel each other out, and you have f of x is equal to 6m, okay? I don't care if you give me this one right here, okay? I can tell you what you're thinking, or you can do that one right there, okay? Either way. Now, if we expect the helium balloon to rise at a constant rate, how high would you expect the balloon to be at 12 seconds, okay? So at 12 seconds, if I plug in 12 for the number of seconds, I should have probably actually put f of n function notation because n was the value we used here. F of 12, meaning 12 seconds, I'm going to go ahead and plug that in, and f of 12 gives me 72, right? 72, 6 times 12 feet in the air. Okay? So, again, hopefully, as you work that out, you got something similar to what I have there. Okay? On the back of the page, we're going to go ahead and just look at these different graphs here. So as I look at number 8, it's a completely horizontal line. Now, what I want you to know is this. If I mark out this point right here, this is 2, 1. If I mark out this point over here, this is 4, 1. This one is negative 1, 1. And this one is, we'll go negative, this is actually 5, sorry. 5, 1. This is negative 4, 1. So what do you notice about each of these points in this graph? All the y values are 1, so I'm going to put down y equals 1. That's my equation right there. Okay? Again, you can check that in Desmos. This one has a y-intercept of, looks like 4, and a slope of 1, 2, 3, 4, 1, 2, 3. So if I go down and over, this is negative 4 and negative 3. So as I write this out, I can put 4/3 slope. So y is equal to 4/3 x plus 4. And that right there would be the equation of that line. Okay. Number 10, now we're going to do some domain and range as well. And here's the thing. If I were to pick any x value out here, negative 1 million, positive 1 million, there would be a corresponding y value that would be on this graph as it goes down, as it goes up. Okay? So as a result, all real numbers will be the domain. Actually, I'll just ARN. I'll just write that out. All real numbers. Okay. Now, on a test, I wouldn't write that out because I want to make sure my proctor, my person that's grading me, knows what I mean by that. If you'd write out in my class, I could understand that, but for the ear test, I wouldn't do that. I'm tired today. Oh, goodness. Now, the range is going to be the exact same thing. No matter what y value I pick here, positive 1,000, negative 1,000, there's going to be a corresponding, if I go over corresponding x value. Down here, corresponding x value, okay? So, again, all real numbers for both of these domain and range. Now, what's the equation? Well, my y-intercept looks like it's -2, and my slope is 1, 2, 1, 2, 3. So I have a -2 and a +3. So -2/3 slope. And right there's the equation line. Again, you can check that in Desmos there. Okay. Absolute value. Okay. Now we're over 3 and up 1. Okay. And it looks to me, I think there's a little typo here. I think it's supposed to be right on those points there. So ignore that. The slopes are supposed to be 1. So as I write this out, I'm right 3, so I'm going to go -3. Remember, it's the opposite. And then I'm going to go up 1. Okay, that's the equation of that line right there. Again, I would double check that in Desmos as I'm trying to make sure I got these right. Now, for the domain, every single x value will have a corresponding y value on that graph. So I'm going to say all real numbers. Okay. Now, for the range, if I go down below here, if I get in the negatives, or if I'm even at 0, when the y value is 0, is there a corresponding x value in this graph? The answer is no. Okay. If I'm at 1, the corresponding x value would be 3. Okay, because that's in the graph. But at 0, there's no corresponding x value that's in the graph. So I'm going to say that the y value has to be greater than or equal to 1 in order to have a part in the graph. Okay. The next one I'm looking at, let's see here. Oh, if I can get off that. Okay. I've got an inverted absolute value. So, and I am this time, interesting. It looks like negative, I'm going to estimate this. I'm not sure if I can get any better than that. 1.5, 1.5, maybe 1 1/3. Okay. So as I jot this down, I'm trying to see on my graph. Oh, my graph was a little bit different in a different key. So I'm going to go ahead and do this. Y, I've got a inverted graph here. X, and I'm to the left 1.5, I'm going to say. So plus 1.5. And then I'm up 5, so plus 5. Okay. So that would be something very, on your test, you don't have anything that's a decimal. It should be just a whole number if you're doing anything. All right, so the domain, what x values play a role in this function? And it's every single one of them, all real numbers. Okay. The y values that play a role in this function start here and work their way down. So y has to be less than or equal to 5. Okay. For the last problem on your page there, okay, we started out with one that was horizontal, had a slope of 0, it was y equals 1. Well, this one's vertical, has a slope that's undefined, and this time it's going to be x equals -3. Every single point along this -3, 0, -3, 1, -3, 2, -3, 3, -3, -1, -3, -2, -3, -3. Okay, so every single point on this graph has an x value of -3. Okay. Now, as far as the range is concerned, doesn't matter what y value I pick. -5, -3 is the x value. +5, -3 is the x value. All of them, every single y value will play a part in this graph. However, the domain, the x values, there's only one x value that plays a part in this graph, which is -3. So there you go. The domain is going to be, the x values that play a role in this graph will only be -3. Okay? Anyways, I know that was super fast. I hope that made sense, what I did. If anything didn't, contact me. We'll go over it. All right? Have a great day. We'll talk to you later.